You know that specific feeling when you're talking to someone, maybe a colleague or honestly even a really smart friend, and you realize about 10 minutes into the conversation that they've completely forgotten what you said at the start.
The glazed over look, the nod that says, I am listening, but the brain says, buffer full.
Exactly. They're nodding, but the earlier information has just fallen out of their head. We see this constantly with large language models. We call it hallucination sometimes, but often it's just memory failure.
Yeah.
And the industry has a pretty visceral name for it that I stumbled across in our research stack for today, context rot.
It is visceral, but it's accurate. It refers to the degradation of coherence as the input gets longer. It's like a leaking bucket. And for
Yeah.
a long time, the solution in the AI world has simply been get a bigger bucket.
Right. Which brings us to the models we see today, like GPT-5 or Gemini 1.5 Pro. We're seeing these massive context windows, 1 million tokens, 2 million tokens. You can theoretically paste a whole library in there. So looking at those specs, you'd think the problem is solved. Why are we even talking about this?
You would think so. But the research we're looking at today suggests that bigger isn't necessarily smarter. Even with 1 million tokens, if you ask a model to find a tiny needle in that haystack, or, connect two complex ideas separated by 500 pages of fluff, the attention mechanism, the literal brain of the AI, starts to scatter.
The signal-to-noise ratio just gets all messed up.
Totally. It's like trying to read a textbook while standing in the middle of a rock concert.
So today we're doing a deep dive into a fascinating paper from MIT CSAIL that proposes a completely different approach. Instead of just giving the AI a bigger brain or a bigger bucket, they're changing how the brain works. We're talking about recursive language models, or RLMs.
And this isn't just a minor tweak. It's a shift from the AI being a passive reader that you dump text onto to an active investigator.
The claim here is that by treating a prompt as an environment rather than just text, you can process inputs 100 times larger than normal. And this is the part that got me. This might be the architecture that finally allows AI to effectively teach itself.
The sci-fi stuff.
Yeah, but before we get to the sci-fi stuff, let's ground this. Recursive language model sounds intimidating. Walk me through the difference between the old way and this RLM way.
Sure. So imagine you have a 500-page legal contract, and you want to know if there's a specific loophole in the confusing appendix at the back. Usually you just paste the text into the chat box.
Direct inference. I paste, I pray, I get an answer.
Right. You take the text, you shove it into the neural network, and you say, answer this. The model tries to hold all 500 pages in its attention at once. It's linear processing. It reads word 1, then word 2, all the way to word 100,000.
And if it's too long?
It either truncates, it literally chops off the end without telling you, or it gets confused. It's like trying to memorize a textbook in 5 seconds before taking a test. You're going to miss details. You're going to hallucinate facts to fill in the gaps.
Okay, so how does the RLM handle that same 500-page contract? Does it just read faster?
No, it actually stops reading entirely. This is the core innovation. The RLM doesn't put the text into the neural network immediately. It puts the text into a REPL.
Oh, REPL. Okay, we need to define that for everyone who isn't a Python developer.
It stands for Read Evil Print Loop. But forget the jargon. Think of it simply as a coding sandbox, a secure place where you can run computer code. So the 500-page contract isn't given to the AI to read. It's stored as a variable. Let's call it variable P.
So the AI can't see the text yet. It just knows I have a variable called P.
Exactly. The AI is sitting there, and it knows I have a variable called P that contains a long text. To read it, the AI has to write code. It has to write a script to say, open variable P, go to page 10, and read the first paragraph.
I like the analogy of the student here.
Yeah.
The standard LLM is a student trying to frantically memorize the book before the teacher takes it away.
Right.
The RLM is a student sitting at a desk. The book is closed in front of them, but they have a notepad, a pen, and they can open the book whenever they want.
That's it. And they can open the book, look up an index, write a note, close the book, and then decide what to look up next based on that note. It turns text into a database that can be queried.
And the recursive part, that implies a loop or repeating something.
That's where they hire subcontractors. The model can write code to split that 500-page text into chapters and then call itself spawn a fresh copy of the AI to go read chapter 1 and report back.
While another copy reads chapter 2.
Potentially, yeah. So it's not just one brain struggling to hold it all. It's a management layer delegating tasks to fresh brains.
Precisely. It breaks a massive problem down into bite-sized chunks that fit perfectly into the context window.
This sounds great in theory, but I'm always skeptical of theoretical gains. I want to see how this plays out in the wild. The source material has this case study called Browse Comp Plus, and it involves, of all things, a beauty pageant and a vegetable stew.
It does. It's a fantastic example of what we call deep research. It shows the difference between searching and investigating.
Set the scene for us. What was the task the AI had to solve?
The prompt was incredibly specific and intentionally vague. It asked the AI to identify the winner of a beauty pageant. But it didn't name the town. It said the town is known for a specific vegetable stew containing fish and a certain condiment, and that a specific festival is held there.
Okay, and the haystack it had to search through?
A corpus of 1,000 documents, about 8.3 million tokens.
Wow.
Just for context for you, 8.3 million tokens is massive. Even the best models today would struggle to maintain coherence with that much noise.
Yeah.
If you fed that linearly, it would likely just make up a name.
It would almost certainly fail. But they set up GPT-5 as an RLM. And here's the cool part. They didn't tell it how to solve the problem. They didn't hard-code a strategy. They just gave it the environment and the tools. The behavior was emergent.
Emergent behavior is always a little spooky. What did it do?
It didn't start reading. It started coding. It realized, I can't read 1,000 documents. So it wrote a Python script to run regex, queries, keyword searches.
It Googled its own memory.
Basically. It searched for vegetable stew, fish, and festival. It found a match for a province in the Philippines called La Union. Then it searched for beauty pageant within documents related to La Union.
So it's narrowing the funnel.
Yeah.
It's ignoring the 990 documents that don't matter.
Drastically. It found one specific chunk of text, index 6, that looked promising, so it zoomed in. It spawned that subcontractor we mentioned to read just that chunk. And it found a name. Maria Dalmacio.
Now, most models would stop there.
Right.
I found a name. Here is the answer. Job done.
Right. But the prompt had a tricky detail. It asked about the winner during a specific anniversary, the 13th anniversary. The text found didn't explicitly say this was the 13th year.
So a standard model might just guess or assume it's right because it found the name.
Often, yes, it satisfies the pattern matching. But the RLM, acting like a detective, paused. It wrote another script. It calculated the dates. It said, if the festival started in year X, is this year the 13th anniversary? It verified the math.
It checked its work.
It checked its work. And only after the math checked out did it return the answer.
That verification step is the killer feature. It's the difference between a parrot repeating a sound and a detective verifying an alibi.
And it mitigates hallucinations. If that math hadn't worked out, the subagent would have reported back false, and the main model would have kept searching.
So that's retrieval. That's finding a needle. But life isn't always about finding one fact. Sometimes you have to connect dots across a huge data set. The sources talk about these benchmarks called oolong and oolong pairs. I assume this isn't about tea.
Not about tea, sadly. These are stress tests designed to break models. SNIAH, the needle in a haystack, is linear. You just scan until you find it. Oolong pairs is different. It has quadratic complexity.
Quadratic complexity. That's one of those terms that makes my eyes glaze over, kind of like context fraud. Break that down for us. Why is quadratic harder than just reading a really long book?
Think of it like a party. Linear complexity is walking into a party and looking for one person named Steve. You just look at each face until you find Steve.
Easy. I scan the room, I find Steve.
Quadratic complexity is walking into a party of 50 people and having to figure out which pair of people have the exact same birthday. You can't just look at one person. You have to compare person A to person B, then person A to person C, then person A to person D, and then move to person B and compare them to everyone.
The number of checks explodes.
Exactly. If you double the number of people, the work doesn't double, it quadruples. Standard LLMs are terrible at this. They can't hold that matrix of relationships in their head. They get lost in the middle of the handshake line.
But the RLM can do it because it has the sandbox. It has Python.
It writes a nested loop. For IEnlist, for JEnlist, it offloads that complexity to the coding environment, which is perfect at loops, instead of the neural net, which is fuzzy at loops.
However, this is the part I really wanted to get to. Giving the AI this much freedom isn't always perfect. The report detailed a test on an open source model, Qwen3 Coder. And Qwen had a bit of a breakdown.
Qwen developed a personality disorder. It became incredibly anxious.
The report calls it obsessive. Describe what happened there because it felt painfully relatable.
So in one of these oolong tasks, the model had to transform some data and verify it. GPT-5 was pretty chill. It grouped things, made a few calls, gave the answer. When decided it needed to check everything? Line by line,
It micromanaged itself?
it triggered thousands of recursive subcalls. It was terrified of getting it wrong. There was this one loop where it calculated the answer, stored it in a variable, and then, seemingly doubting itself, threw the variable away and started the calculation over.
It's like the neurotic intern. You send them to write an email, and they write it, delete it, write it again, check the sent folder, realize they haven't sent it yet, and start over.
It did that 5 times in a row. It was stuck in a loop of self-doubt. And the tragic part, after burning through all that compute, it sometimes still gave the wrong answer.
That is tragic. But it highlights a real risk here. If you give an AI agency, if you give it the ability to spawn subagents and write loops, you're also giving it the ability to spiral.
Which is why the infrastructure conversation is so important. You can't just hook this up to a credit card and hope for the best. You need a system to manage the workers.
The sources mention some heavy-duty plumbing needed to keep this safe. Terms like Envoy proxy, Prometheus, circuit breakers. It sounds like we're building a nuclear plant, not a chatbot.
In a way, we are. Think of Envoy as your traffic controller. If a user asks a simple question and the model suddenly tries to spawn 5,000 subagents, like our anxious friend Quinn Envoy steps in, it manages the load so the server doesn't catch fire.
So it queues up the interns so they don't all storm the office at once.
Exactly. And Prometheus is the vital signs monitor. It's watching latency, error rates, and depth. It sees if the model is diving too deep into a recursive hole.
And the circuit breaker. That sounds like the kill switch.
It is the kill switch. If the model starts that check the door loop 5 times, the circuit breaker trips. It cuts the process and says, stop, you're done. Give me the best answer you have right now.
We basically need to build an anti-anxiety medication into the server architecture.
Or just a really strict manager who says, good enough, ship it. Or just limits on how much money it can spend.
Which brings us to the bottom line. Because when I read recursive calls and thousands of subagents, all I see are dollar signs. If I'm paying per token, isn't this approach going to bankrupt me?
You'd think so. This is the cost paradox of RLMs.
Paradox implies the opposite happens.
It does. In the MIT study for that specific beauty pageant task, the RLM using GPT-5 was actually cheaper than the standard summarization methods.
Cheaper. But it's doing way more steps.
It's doing more steps, but it's using cheaper labor. Think back to the notebook analogy. If I ask you to find a fact in a 1,000-page book and you are a standard LLM, you have to read or process every single word on every single page. Neural processing is expensive. You're paying premium rates for the AI to read the word "the" thousands of times.
Right, and burning tokens on fluff.
But the RLM ran a regex search first. That search cost almost nothing. It's just basic code running on a CPU. It filtered the 1,000 pages down to maybe 5 relevant pages. Then it only used the expensive neural brain to read those 5 pages.
I see. You're trading expensive neural tokens for cheap CPU cycles. You're using a cheat map to find the treasure, and only digging when you're at the X.
Exactly. Code is virtually free compared to inference. By using code to navigate, you save a fortune. However, there is a catch.
There's always a catch.
It's high variance. The median cost is low. But the tail cost, the one time out of 100 where the model goes full Quinn and spirals, that can be astronomical.
Standard models are predictable, like a taxi meter. You know roughly what it'll cost. RLMs are like Uber surge pricing.
Yeah.
Usually cheap, but occasionally shocking if you don't pay attention.
Which brings us back to why you need those circuit breakers. Without them, your bill is a gamble.
So, zooming out, we've gone from models that predict the next word to models that plan an investigation. This feels like a significant step toward what people call agentic AI.
It is. We're moving from passive knowledge retrieval to active problem solving. An RLM doesn't just know things. It knows how to find things. It knows how to use tools to compensate for its own limitations.
And the video script source touched on something that I think is the real end game here. Self-improvement.
Right. Think about the loop we described. The model writes an answer, verifies it with code, and gets a confirmed correct result.
That confirmed result is data. High-quality data.
Exactly. We're running out of high-quality human text on the internet to train these models. We've scraped the whole web. But if an RLM can generate its own questions, answer them, and crucially verify the answers with math and logic, it can generate its own training data.
It writes its own textbook.
And because of the verification step, that textbook is cleaner than the internet. It's fact-checked. It's better than the raw data we give it.
That's the exponential curve right there.
Yeah.
If the AI becomes the teacher, the student, and the grader, the speed of evolution changes.
It creates a flywheel effect. The smarter the model gets, the better data it produces. The better it produces, the smarter the next model gets.
Which leaves us with a bit of a provocative thought to wrap up on. We always talk about human in the loop. We are the safety net. We label the data. We check the output.
We are the bottleneck.
Exactly. If an RLM can iterate on its own code, generate synthetic data that is better than ours, and verify its own facts, at what point do we stop being the teachers?
We might move from being the teachers to being the goal setters. We say, go find the beauty pageant winner or cure this disease, and then we just stand back.
And hope the circuit breakers work.
Definitely hope the circuit breakers work.
I want you to think about how you solve problems today. When you're faced with a massive, complex task, do you try to hold it all in your head at once? Or do you break it down, write some notes, and investigate recursively? Maybe we have more in common with these RLMs than we think. Thanks for joining us on this deep dive.
See you next time.